Hi, my name is James Rambaud and I am the soil carbon sequestration technician here in Johnstown Castle. The great environmental challenge of this century is the need to stabilise atmospheric concentrations of greenhouse gases. In order to achieve this, we, the caretakers of this planet, need to reduce our dependence on fossil fuels and find ways of removing greenhouse gases from our atmosphere.
The scope of the issue we face is very challenging. Currently, sources of greenhouse gas emissions from human-related activities release 34 gigatons of CO2 into the atmosphere annually. At present, there is no hope for a radical reversal of these rates of emission. Aside from reducing our fossil fuel use, there is one method we can all use to try and stem the rate of greenhouse gas growth. This involves the sequestration or capture of atmospheric CO2 as organic carbon in our soils. Carbon stored in soils is very beneficial. It improves their structure, their water holding capacity, their productivity and their biodiversity. Europe's recent Green Deal aims to prevent climate change by bringing down carbon emissions significantly by 2050. Beef and dairy production are the largest Irish agricultural industries and the main cause of the sector's emissions. Reducing the national herd's carbon emissions as much as possible while feeding a growing population is going to be very challenging. Here at Teagasc Johnstown Castle, we use a range of equipment to monitor and track CO2 and soil carbon, such as eddy covariance towers, elemental analyzers and pneumatic soil corers. These enable researchers to look into improving the national herd's carbon footprint. The main strategies being investigated in order to achieve this include improving efficiencies, adopting low emission technologies and carbon sequestration.
Okay, so I'm going to talk to you briefly about what exactly soil carbon sequestration is and how it happens. So we have our plants, which, as we all know, photosynthesize. They use solar energy combined with carbon dioxide, which is our big problem word at the minute, and water to create simple sugars such as carbohydrates. So they use these simple sugars to grow biomass. This biomass is above and below the soil. Now, following decomposition, it eventually becomes a stable form of carbon in the soil. I just demonstrate here three types of sod that I have, one from a woodland, one from a long-term grassland and one from a tillage soil. So we see here with the woodland, which has been woodland for 20 plus years, we have deep roots which go right to the bottom of the sod. You can see it's very stable, it's in one piece. The water is well held within the soil. There is ample pore space for water to move through, but not enough pore space for water to wash away the soil. Here we have our grassland, which again has been grassland for 10 years plus. You can see it's much shallower. There's quite a dense biomass on the top here. They're quite deep rooted, not as deep as the woodland, but it holds firm together. It's well structured. Again, another very good method to sequester carbon. And then we have our tillage. And the tillage, as you can see, it's very crumbly. It doesn't really hold its structure too well. There's not really a great root mass. Very compared to the woodland, there's very little biodiversity in the soil. However, this is the sod that has the most potential to sequester carbon. With careful management, such as minimum tillage, or we're looking into very deep ploughing, etc., there is an awful lot more potential to sequester carbon long term in tillage soils.
Okay, so when we hear carbon dioxide, the majority of us think of it as being a bad gas, but in actual fact it's a normal constituent of the atmosphere. The issue is when there's too much carbon dioxide. So I have set up a little bit of an experiment here just to demonstrate exactly what happens when there's too much carbon dioxide present in the atmosphere. So we have a little temperature sensor here that's reading 19.2 degrees at the minute. Both these bottles have distilled water and are filled with ambient air. So they have normal levels of carbon dioxide in them. I have two effervescent tablets here that I'm going to drop into one, which will release carbon dioxide. I will close the lid on both and then add a heat source. And normally what we should see is an increase in temperature over the standard in the carbon dioxide bottle versus what is normal ambient air. So I've just dropped the effervescent tablets in. You can see it's starting to fizz now. I'm just going to place the lid on top and let the carbon dioxide build up inside the bottle. Okay, so I'm removing our thermometer, adding the lid to our control, flicking on our heat source and placing it in front. So now in theory our carbon dioxide bottle should heat up faster and to a higher temperature than our control. The lamp here actually represents the sun, which was both a light and heat source, and the two bottles represent our atmosphere under normal conditions and under exaggerated carbon dioxide conditions. Okay, so we've left the experiment overnight. It's actually got a bit cooler in here. The heating's been off, obviously. So this is our control. We are now just about 17.5 degrees Celsius in our control. And if we look at our CO2 bottle, then we are up around 26.7 degrees or so. That just goes to show a temperature difference of 10 degrees Celsius, and that's just here in the lab in front of us. That's what's happening in our atmosphere at the minute when we are emitting such amounts of carbon dioxide into the atmosphere.